The cloud needs a power plant. AI was sold as weightless magic, running somewhere beyond geography, beyond wires, beyond fuel. But the next platform war is not only being fought with chips and code. It is being fought over reactors, gas plants, transmission lines, pooling water, and who gets priority when the grid runs short. Microsoft, Amazon, Google, and others are racing to secure always-on electricity before the public understands what is being taken. That is the trap. The cleanest, most reliable power is being locked behind private contracts, while ordinary households are left with rising bills and weaker grids. One country is moving computers toward cheap power. Another is letting corporations carve the grid into private zones. And the first bill has already arrived. PJM runs electricity markets for 67 million people across 13 states. Once a year, it buys future capacity 3 years before delivery. So the grid has enough reserve power when demand spikes. In June 2025, that auction cleared near $270 per megawatt day. 1 year earlier, it cleared at $29. That is an 833% surge in 12 months. Household capacity costs jumped from $2.2 billion to $14.7 billion. The next auction, for June 2026 onward, hit the price cap near $329 per megawatt day. Without that cap, prices would have reached $389. The cap saved consumers $13 billion. Then, the warning got darker. Internal filings showed prices smashing into an even higher cap, yet PJM still missed its own reserve target. Even after prices exploded, the grid could not buy enough backup power. Price was no longer the only problem. The system itself was running short. The cause was not mysterious. Demand was moving faster than the grid could adapt, and data centers were responsible for roughly 63% of the price surge. Families inside PJM's territory may face about $70 more per month by 2028. Across 8 years, the added cost is estimated between $100 billion and $163 billion. That is the hidden AI bill. Then came 3 Mile Island. In September 2024, Constellation Energy signed a 20-year power purchase agreement with Microsoft to restart Unit 1 in Pennsylvania. The site sits close to Unit 2, the reactor linked to the worst nuclear accident in U.S. history in 1979. Unit 1 did not close in 2019 because it was unsafe. It closed because it stopped making enough money. Now it is scheduled to return in 2027. 1 year ahead of the original 2028 target. The Department of Energy closed a $1 billion loan to reduce financing costs. Constellation is spending $1.6 billion on the restart. The license runs until at least 2054. Microsoft receives the full output for 2 decades, enough power for roughly 800,000 average homes for a year. The electrons still enter the shared grid, but the clean energy credit belongs to Microsoft through 2047. That detail matters. The deal brings $3.6 billion in state and federal taxes, 3,400 jobs, and $16 billion added to Pennsylvania's economy. Politicians celebrate those numbers. But the deeper shift is harder to see. A public power asset is becoming a private AI reserve, and everyone else pays more to stabilize what remains. This is where the story stops sounding like technology and starts sounding like control. Many people assume solar, wind, and batteries can simply fill the gap. But AI data centers do not run like ordinary buildings. They demand 5 nines reliability. That means 99.999% uptime, or roughly 5 minutes of downtime per year. A frontier model training run can cost tens of millions of dollars and run for weeks. One power flicker can corrupt the job and force engineers back to a checkpoint. 5 minutes is everything. Solar disappears at night. Wind can vanish for days. Batteries large enough to guarantee 5 nines at national AI scale do not exist anywhere. The heat problem is just as severe. A modern NVIDIA server rack can draw 8 to 10 times more power than standard racks used only a few years ago. New AI facilities use direct liquid cooling, moving water across chips at flows large enough to serve small towns. That is why hyperscalers want nuclear power. It is carbon-free, massive, and always on. But when clean firm power is reserved through corporate contracts, the public grid absorbs the messy leftovers. The old plants do not disappear. They stay alive for everyone else. Reuters reviewed PJM filings and found about 23 coal, gas, and oil plants scheduled to retire in 2025 or shortly after. Since January 2025, 13 retirements were delayed or canceled. Brandon Shores, Maryland's top climate polluter in 2022, will now run until May 2029. Its owner is Talon Energy, the same company selling nuclear power to Amazon. Then, look at Loudoun County, Virginia, about 40 miles or 64 kilometers west of Washington, D.C. This is Data Center Alley. It handles roughly 25% of North American internet traffic. Zip code 20147 may be the internet's physical brain. The county has about 200 data center buildings, with 117 more in development. A single new campus can request enough power for 150,000 homes. One campus, one customer. Dominion Energy is planning huge transmission upgrades, including the Golden to Mars line, a 22-mile or 35-kilometer corridor through neighborhoods, schools, and farmland. Dominion's 2025 to 2029 investment plan has climbed to $50.1 billion. Those costs do not stay in Virginia. They spread across the 13-state regional grid. Virginia's own audit commission warned the state would need a new 1.5-gigawatt natural gas plant every 2 years for 15 straight years just to meet data center demand. That is not a tech story. That is an energy emergency. Now comes the most dangerous illusion: efficiency. NVIDIA's Blackwell platform is rolling through data centers in 2025 and 2026. At system level, it can use up to 25 times less energy per inference token than the previous generation. That sounds like salvation. It is not. The International Energy Agency expects global data center electricity demand to more than double by 2030. Its base case reaches about 945 terawatt-hours, up from 415 terawatt-hours in 2024. That is slightly more than Japan's annual electricity use. By 2035, the forecast rises to 1,200 terawatt-hours. In the United States, data centers could consume more electricity than steel, cement, chemicals, and aluminum combined. Lawrence Berkeley National Laboratory reported that U.S. data centers used 4.4% of all electricity in 2023. Within a few years, that share could nearly double or even triple. Raw use could rise from 176 terawatt-hours to as much as 580 terawatt-hours in 5 years. This is Jevons' trap. In the 19th century, William Stanley Jevons saw steam engines burn coal more efficiently, yet total coal consumption climbed. Cheaper use created more use. AI is repeating that pattern. When each query gets cheaper, AI spreads into search, customer service, coding tools, office software, agents, analytics, and every product that can justify another automated feature. Each task is small. Together, they consume the savings. The IEA expects about half of new data center demand through 2035 to be met by renewables, with natural gas covering another large share. That changes the supply mix. It does not remove the demand shock. China saw the geometry problem early. In February 2022, the state launched East Data, West Computing. The plan divides the country into 8 national computing hubs and 10 data center clusters. Eastern clusters near Beijing, Shanghai, and the Greater Bay Area handle fast-response urban workloads. Western clusters sit in Inner Mongolia, Ningxia, Gansu, and near the Gobi Desert. By late 2024, about $6.1 billion had already gone into the 8 hubs. Why build there? Because the West has huge hydro, wind, and solar resources that local populations cannot fully use. Instead of forcing all that power east through crowded transmission routes, China moves eligible computing west through high-capacity fiber. Routine workloads already meet a 20-millisecond latency target between eastern cities and western hubs. In Ulaanbaatar, Inner Mongolia, planned data center projects total about 10 gigawatts, with companies including 21 Vianet, Huawei, and ByteDance. New hub facilities must hit power usage effectiveness of 1.2 or lower. Some new builds reach 1.04. The global average is closer to 1.5. China's data center electricity use is still forecast to grow 19% per year from 2025 to 2030. But the strategy is different. Put computing beside abundant power, not scarce power beside every corporate campus. The U.S. answer is more private. Through 2024 and 2025, tech giants rush towards small modular reactors. These reactors typically produce 50 to 300 megawatts each. Amazon invested $500 million in X Energy, aiming to unlock more than 5 gigawatts by 2039, enough for about 3.8 million homes. The first project, Cascade in Washington state, plans 12 modules in 3 blocks for 960 megawatts on a compact site. Google signed with Kairos Power, including Hermes 2 in Tennessee. Meta explored multiple gigawatts. Equinix partnered with Oklo. Prometheus Hyperscale followed. Many designs serve data campuses directly, sometimes behind the meter. That means private lines can move power from generator to customer without fully using the shared grid. The public is excluded early. Amazon's Susquehanna deal shows the fight. In March 2024, Amazon Web Services bought a data center campus beside Talon Energy's Pennsylvania nuclear plant for $650 million. A private connection had been approved by FERC in 2015. When expansion came, utilities objected, warning that hundreds of millions in grid costs could shift to everyone else. Regulators blocked the expansion. The dispute moved to court. The original connection kept operating. That is the new rulebook. Microsoft, Amazon, and Google are no longer just software companies. They are becoming sovereign tech utilities, massive energy buyers, reshaping grids through contracts, campuses, reactors, and private wires. There was no grand public vote on this shift. There were press releases, regulatory filings, and letters from officials helping projects move faster. Pennsylvania Governor Josh Shapiro wrote to PJM supporting faster interconnection. The central question remains unanswered. Who gets the power? China is treating energy, geography, latency, and computing as one national system. The United States is allowing 2 grids to emerge inside one country. A premium grid for AI giants, and a strained public grid for everyone else. Chips can be copied. Software leads fade. Power infrastructure takes decades. The AI war is physical now, fought with atoms, water, steel, and land. The winners may be decided before most people even read the bill. The cloud was never weightless. It was just sending the cost somewhere else.